James on it? Are y'all with me? Wish we could get up and do some like get you awake this morning, but I'm gonna set my timer for things because I like math so much that I sometimes go over on my time. So we're gonna get started in just a second. Okay. All right. 5th grade lesson. So we're ready for math this morning? Are you excited?
Yeah.
Oh, yeah, sound excited? Yes. All right, here we go. So the first thing we're going to do this morning is a little quick number sense routine to warm us up to get us ready for the lesson. So just look at this model that's up here right quick. Take a look at that. And I want you to think about what equation you could write to match this model that you see up here. Just look at it for a second. Think. It's been a while since you've written equations, hasn't it? Right? Because you've been out for a little bit. Are you thinking? Now I want you to turn and talk to the person sitting next to you. What equation do you see up here that you could write? And if you want to write on the back of your paper, feel free.
Or I can write all the circles and I can put 6, 24, or 24. What equation?
What does the 4 mean?
6, 4.
Is the number of circles?
6 times 4 is an equation. 6,
So I want you guys to talk to each other and use the words number of groups and size of the group. And say what you just said, but use the words number of group and size of the group. Talk to each other about that. What do you got? You see 6 on front. What's the 6 represent?
The dots in the circle.
What's the 4 represent? The circle. So if you could use the word number of groups and size of the group, which of those would be the number of groups? Which would be the size of the groups? Talk to your people about that. Oh, and I forgot to ask. Does one of these pins write on this one? No?
You have to do annotate though.
Okay.
So push that and then annotate. Is there one that says annotate? Yes. Now you can write. You can move that just with your finger. Or there you go.
There we go. Let's see if this works. Oh, look at that. Okay, so back with me, everybody. So you guys were talking. I walked around to some of your groups. And who wants to share what equation they were talking about here, what they saw in this model? Back in the back. What did you see?
Me and Trey was talking about how we seen, well, he said this, that he saw 6 in every group, and there was 4 groups. So he said that he could do 6 4s, and then 6 times 4.
Okay, so they said that, did y'all hear what they said? Turn and tell your neighbor what she just said about groups and size and how many were in each group. Turn and tell your neighbor what she just shared with us. So they had, okay, come back with me. So what were they saying? What about groups and number of groups? What was she saying? Sorry? They're groups. Which one are groups? 4 or 6? How many groups do you see?
4.
Oh, there's 4 groups. So the 4 is the number of groups. Would y'all agree? 4 is the number of groups. So if we're looking at 6, tell me your name, sweetheart. Lachey said that she saw 6, and what did she say that was? The amount in each group. Would you agree with that? Mm-hmm. So she had 6 is the size of the group, right? So with multiplication, you guys know this because you're 5th graders, we know that we're taking a number of groups and we can repeatedly add those size of the groups to get the answer, or most of you probably just know that 4 times 6 is 24, right, without having to multiply or add those together. Was there another equation that someone came up with besides 6 times 4? What'd you come up with?
24 divided by 4.
Oh, did y'all hear that? 24 divided by 4. And what was the answer? 6. So in this equation, what's the 4 represent, y'all? Turn and tell your neighbor what the 4 represents, and turn and tell your neighbor what the 6 represents. Oh. Okay, back with me. What does the 4 represent? The 4 is what? The number of groups. Would you agree? We have 4 groups, so it's the number of groups. And what does the 6 represent?
The
Size of the group. I wonder if you could do one more thing for me since my timer went off. Talk to your neighbors, is there another multiplication equation we could have written? What would it be, and which one should we write for this model? Should we write this one or the other one that's out there? Talk to your partners. What's the other one? Okay, come back with me. Quick turn and talks, right? So, what was the other multiplication equation we could write, hun?
I think it might be 24 divided by 6.
Oh, could we do 24 divided by 6, y'all? So, what's the 6 now? Six, I did say multiplication. It's okay, let's talk about that one because that's a great one. What's the 6 tell us now? I hear it's the number of groups. Do y'all agree?
Yeah. No.
Oh, it's not? Because how many groups do you see?
4.
There's only 4 groups. So did these, what these represent change? Absolutely not. This 6 is still the size of the group, and this 4 is the number of groups we could create, right? So it didn't matter. It still tells us the same thing. So somebody told me the other multiplication equation that it would be. 4 times 6, I heard. So I ask you, which one of these is correct? What do you think?
6 times 4 because there's 6 4 times versus not 4 6 times.
Oh, okay. What do you think? Anybody else have a different thought on that? No? No different thoughts? So let me tell you what this multiplication sign means, okay? This multiplication sign actually means groups of. So now that you know that that sign means groups of, which one of these is it? If you replace the words groups of with that multiplication sign, say 6 and then groups of 4, or is it 4 groups of 6? Turn and tell your neighbor, what's it going to be? Which one's the right way to write it? Okay, so come back with me. What is it?
4 times 6.
It is 4 groups of 6. So for this model is 4 groups of 6. But could we make 6 groups of 4 out of this? Yes. So when we have a model, our multiplication has to match it. But when we don't have a model, it doesn't matter because we know multiplication is commutative, right? So here's what I want you to do is to keep this in mind. You got this in mind of what that multiplication sign means? Groups of? And we're going to explore that a little bit more in the case. Somebody tell me how to erase. Anyone? This? Do I have to do it? Is there easier way?
I just pushed the X right
This
there.
X? Oh, I'm going to feel so proficient with technology when we get going. Okay, so our learning for the day, that was our number sense routine, a warm-up of reminding us of what we know about multiplication, because it's been a while since we've been in school, hasn't it? So today you're learning to connect the understanding of multiplication that we just talked about to whole numbers of fractions. So we're going to be multiplying, looking at whole number and fraction multiplication. You're going to know you're successful when you can create models. And your models this time are going to be pictorial models on a number line that's on your sheet. And you're going to be able to explain what's the same about each model or what's different. You think you can do that? Y'all are not convincing me. Do you think you can do that? Oh my goodness. One more time. Do you think you can do that?
Yes.
I know you can, right? So I'm learning to connect. Remember, the whole time when you're thinking today, I want you to connect what we just refreshed our memory about, multiplication, to what we're doing with these problems we're going to solve, okay? And remember, you have to not only create the model, you have to be able to explain the models, and you have to be able to talk about how they're the same and how they're different. Y'all with me? All right, so on your task that you have in front of you is John. How many of you like to run? A couple people? Yeah, I like to run. I like to run too. I run half marathons. I've never gotten to the full marathon yet, but I'm working on it, right? So I love to run. So when you're running, you want to do a race, you train, right? So John has been running. He ran a half a mile every day for 3 days. I need you to help me figure out how far he ran. And you remember, part of our success criteria is to model and explain. So if you flip your paper over, you're going to see this exact same problem. And I've given you a little line there to kind of help you model how far he ran. And then Sam, he ran 3 whole miles. Okay? But he ran half of that distance on Monday and the other half on Tuesday. I want to know how far he ran each day, and you're going to use that line to explain, or to show me the model. Are y'all with me? All right, I'm going to set my timer. You and your partners are going to work together to solve this problem, and I'm going to come around and ask you some questions about what you're thinking. And remember, model, explain, and how are they the same and different, okay? All right, set my timer. You guys go ahead and get started.
So we ran 1/2 of a mile every day for 3 days.
We could do that math by basically, we did, okay, so that's 1/2 a mile. That's 1 whole of a mile because 2 halves is a whole. And then
That would
1
be-
and 1/2.
So how could you show that on the line?
You could do a half, and then equal 1.5.
Okay, so what are you gonna do to show that on the line? Do what you said. Okay, above it, yeah. So what does that 1/2 represent? Remember what we talked about connecting connecting multiplication of whole numbers that we just talked about to fractions and whole numbers? What does that 1/2 that you're putting there represent? Is it the number of groups or the size of the group? It's the size of the group, he says. So what you're looking for is what? So if the size of the group is 1/2, what's the number of groups? The days, gotcha, 3. So how many groups are you gonna create? 3. So I want you guys to think about what multiplication equation would you write to represent what you're modeling here, okay? And then think about how that's different when you go to the next one, okay? Are you guys talking with each other yet? Or you having a little private time before you talk? Have a little private time, that's okay. So talk to me about what you're thinking here on this first problem. I know this, let's look at all 3 of yours. You're very similar. Why did you all choose to hop on the line 3 times?
Because, well, it said for 3 days, so we kind of each line a day. So basically, 1 day, 2 days, 3 days.
Okay.
And
So-
then that-
Does that 3 days, would y'all agree that's what you did? These were your 3 days? So is that 3 days the number of groups or the size of the group?
size group.
What do y'all think? Is the 3 days the size of the group?
No, it's the number of the group.
Okay, why do you say so?
Because it's telling you how many days he ran.
Oh, so how many days he ran is the number of groups, right? So then what's the size of the group that you're jumping there?
Basically half a mile.
Half a mile, okay. So he's jumping 3 half a miles. So we're trying to find the total there. What I'm wondering is, what equation could you write, based on what we did with number sense routines this morning, what would the equation look like to show this number line hopping that you did here, okay? I want you to talk to your group about that, and I'll be back in a minute to check on you. Oh, what's going on over here? Talk to me about your models. Have you guys talked to each other? No? Let's take a look at these 2. Y'all looking at these 2? So look at these. How are they the same? How is this one and this one the same? They have 3. Why do you think, because I know that you hadn't written anything yet, but why do you think they have 3 jumps on their line? Remember in our problem, John is running a half a mile every day for 3 days. How far did he run? So why do you think they have 3 jumps? Well, y'all want to help him out here? Why do you have 3 jumps? What does the 3 represent from the problem? How many days he ran. So I want you to think about, what does that represent? The number of groups or the size of the group? Remember, our learning target today is to connect what we know about multiplication, whole numbers, to whole numbers and fractions. So what does that 3 represent? Number of groups or the size of the group? The number of groups. Would y'all agree? So that's why they have 3 groups. Am I following you? So what I'm looking at here is these look a little different. You see the difference here? What's the difference here? What's going on with, is that Jake? Is that Jack, sorry Jack. And Aubrey? It's hard to read upside down. What's different in Jack's and Aubrey's? They both have 3 groups, but they look a little different. Okay, so his is jumping 1 hole. How does she know it's 1 hole? Let's look at them. Oh, it went over 1, but let's look at this first one. What did it jump to? A half one, and this one jumped to what? It jumped a whole step instead of a half a step, right? So do you think you guys can work together to kind of modify Jack's there to help him match Aubrey's. And then I want you all to think about what's the equations here. What's the equation that's represented here? Remember our connection to multiplication? What equation can you write to show that, okay? All right, Aubrey, I'm going to take a picture of yours. Maybe. I do not show names. I'm not having one look. Okay, so y'all talk about, what are you talking about now?
How to get.
Yep, help him get his with the correct size of the groups, right? But also your equation, okay? So y'all talk about what should the equation be. Remember our connection to whole numbers earlier. Oh, look at all this nice writing you have back here. Talk to me about what's going on. Tell me about your models.
In our models, we had I'll just call it 3 jumps from. So they both, of course, started at 0. Then John ran half a mile each day, so 1/2 plus 1/2 is 1. Then 1 plus 1/2 is 1 1/2.
Oh, interesting. So his number of groups was what in this?
3.
3. But in the oh, good. You just told me what I wanted to know, which is the 3 is the number of days, right? And the size of the group is how much?
The size of the group is that. You mean that the size?
Yeah. If he did 3 groups, what was the size?
I do need to fix like this stuff.
1 and 1/2.
What do you think about that? Tell me your name.
Trey.
Trey. Trey, what do you think? She said the size of the group is 1 1/2.
For Sam, it's 1 1/2, but for John, it's just 1/2.
Oh, for the size of the group is what you're saying. So each jump that you took, tell me why you're changing that.
Because, oh, wait.
No, I think sorry, I didn't mean to confuse you. You had it right the first time there with these halves in there, right? So he ended up right here. So let's take a look at the 2 problems. You see the 2, John and Sam? What did you notice is the same about how much they ran?
They both ended up with 1 and 1/2 at the same point.
Really?
Not at the same point, at some point.
At some point, right? So who did it take a little longer to run 1.5 miles?
John.
It took John, so he took 3 days to do it.
The
Yeah.
different thing about them is that they got that on different days, and that Sam ran a day in total. John ran more days though.
Oh, gotcha. Okay, so I'm looking at your models. I love your explanation. So you're hitting our success criteria. You've made models, you've explained. What I'm wondering about with our success criteria, didn't have it up there, but I want to push you to see if you can write an equation. Remember those equations we did at the beginning, number sense? What would the equation look like for this versus this? Would they be different or would they be the same? I want y'all to talk about that and about what that equation, a multiplication sign means. All right, guys, how's it going up here? Did y'all figure it out? You did? Awesome. So talk to me about your models. You guys talking to each other? So what about the first one? I notice he has halves written here. You have a couple halves. You have started at 1 and gone over here. So talk to me about your different models. What are you thinking?
1/2.
So it's just like John ran 1/2 of a mile every day for 3 days. So it would be 1/2, then the 1/2 again, which would turn into a 1, and then 1/2 added to 1,
Okay.
which would be 1/2.
Okay. So he's saying, tell me your name, honey. Chase. Chase is saying that he's running a 1/2 mile each day. Would y'all agree? So is the 1/2 mile that he's running the number of groups or the size of the group?
And then 1 1/2 times 2.
Is the size of the group. So how many groups are we going to create that are half in size?
Never mind.
3. So I see 2 here. Where's the third one? So where do we start on the number line, guys? 0. So where's the first group that we could show on this line? Can you help him out? Shane? Is it Shane? Sean. Sorry, Sean. Can't read upside down. Mason. That's my son's name. Where would the other group be on this? He has the 2 here. Where would the other group be?
I could see it.
Oh, from 0? What do y'all think? What do you think, Mason?
Watch how
Why did he start at 0 and you didn't?
when I write fast, that's how
You don't know? It's okay. You could have a reason. Did you have a reason why you started at 1? No, not really. You just started there. But were you thinking the same thing, that you needed to jump 3 1/2s? Because we had 3 groups? So can you fix this for me about showing that other group in there? And then Sean and Mason, I want you to talk with, we got about another minute of our time to explore. I want you to think about, help Chase write an equation to match that first model. What would that look like? Remember our connection to our number sense routine? What is multiplication? How could we write a multiplication equation there? What does that multiplication sign mean? Y'all remember from this morning? Groups of, right? So how could we show that with an equation? I'll check on you in a minute. All right, guys. How's it going? So, tell me about this model down here.
So we divided it in half, and then we saw that 1/2 was 1 and 1/2.
Oh.
And we multiplied that by 2, and then we got 3.
Okay, so when you said you divided it in half, what made you choose to divide this in half?
Because I knew that it could be divided by equally.
Okay, because what in the problem let y'all think you needed to divide this in half?
Because it says he ran half the distance on Monday and then half on Tuesday.
Oh, gotcha. So if you're showing half of this, you just went right in the middle. Is that what you were thinking? So how is this? So what's the answer here? How far did he run on Monday? And Monday and Tuesday he ran 3 total. But how far did he run each day?
1 and 1/2.
Each day. How far did Sam run?
3 miles.
Did Sam run? Look at what your model's showing me here. How many did Sam run in his 3 days? Oh, not Sam. Miss Loves is saying the wrong. Nate, how far did John run in his run?
He ran 1.5.
What? You mean they ran the same amount here? On Tuesday? And he ran the same amount, ran the same amount in 3 days, and he ran the same amount as John and Sam ran the same amount, but it took them a little different days, right? So how is this model like that model? That's what I want y'all to talk about before we get back to our share discuss. How is this model same as this one, but also how is it different? Let me take a picture of yours right quick, if you don't mind. This thing won't work on Face ID because it can't see my face. And I don't know my password. Take a picture of that one down there. Okay. All right, let's kind of come back together and we're going to share some solutions out. And I am going to take a picture of this if you don't mind. I didn't get back to everybody that I wanted to talk to. But we're going to share some solutions, assuming Miss Loveless figures out how to work the board again. Woo, what do you think?
Maybe.
Have faith in me?
Possibility.
Let's try it. Screen share. Starting our broadcast. You guys did an excellent job. I wouldn't have believed you've been off at Christmas break for 2 weeks. So, very nice working together. Okay. So what we're going to do now is called our share discuss time. So we're going to be sharing. I'm going to put up some solutions that I've taken pictures of throughout the room, and you guys are going to be talking about them, okay? So I'm going to put up the first solution. I'm going to ask you a question about it, and I want you to talk to your partner, and then we'll come back together. Because remember, our goal for the day was to connect what we know about multiplication of whole numbers. Remember our number sense routine? To multiplication of whole numbers and fractions. And you had to model and explain, and I pushed a whole bunch of you to write equations. Did an excellent job out there. So let's get this first one up right here. Let's see if I can zoom in. Maybe? Is that look? Now we're only going to look at this first top one. Don't look at the bottom one yet, okay? So look at this model that Aubrey has here, and I want you to think about, and I saw this a lot throughout, but we want to make sure everybody's on the same page. Turn and talk to your neighbor. Why did she jump 3 times? On this, oh no, whoopsies.
Wow.
Hold your hand still, Miss Loveless. There we go. How about that? I'll put it down. So, why did she jump 3 times? And what does that represent in multiplication language? Talk to your partners about what that represents and why she jumped 3 times.
It's 3 days.
Okay, so let's come back together. Talk to me about what you and your partner said. Uh-oh. Y'all, the struggle is real. That's okay. So go ahead and tell me what you and your partner said about why they jumped 3 times and how that relates to multiplication. Who wants to share? Right there, sweetie.
When I heard that he ran 3 days and I jumped 3 times, I thought of the jumps as how many days he ran,
Okay.
and in multiplication, it would be how many groups, like how many groups of miles he ran.
I love it. Did y'all talk about that in your partner group? That 3, he jumped 3 times. What in the problem told him to jump 3 times though?
The question that says Johnny ran 1.5 of a mile every day for 3 days.
For 3 days, right? So the number of groups in this problem is actually days, right? So 3 days, 3 groups, and you said this would be the number of groups, right? So I'm wondering here, why did Aubrey choose to jump the distance she jumped, and what is the distance she jumped and why? And I want you to look at that compared to this one. It also has 3 jumps, but I want you to think about what's the difference in this one, and I can't put them both up there at the same time, I'm not smart enough for that one, and this one. Are y'all with me? Whoops, try not to make you sick. That one and this one. So talk about now, y'all said that was the number of groups, so this person jumped 3 groups. Would you agree? So what's different though about this solution and the last solution? And use the word size of the group as you talk to your partners about what's different.
They skipped over.
Interesting. The other one didn't, did it? Okay, so let's come back together and let's talk about let's talk about the difference in this one and the first one that we looked at. That first one we looked at versus this one. Who can talk to me about what you and your partners said about that? Yeah, in the back.
I just thought of this, but basically like the jumps aren't even on that one because like first there's like a half jump and then there's like 1 whole of a jump. They said no whole.
Did y'all talk about that in your partner group? So if we were going to give them feedback on how to adjust this model, what would we tell them they needed to do to adjust the model?
Make the jumps even.
Oh, because we know in multiplication, your jumps have to be what? Equal, right? And even. They have to be the same. The size has to be the same if we're doing multiplication. We have to have 3 equal groups. So when we're looking at that first one, we saw the 3 equal groups of a half. So that half represented the what? Number of groups or size of the group? What's the half? Size of the groups. So I want you to look at this next equation right here. So this is the equation that someone wrote for that first problem. Can you see that? So they wrote 1/2 times 3 or 3 times a half. And I did ask you to write an equation in the task, sorry. But so I'm wondering, which one of those is correct? I want you to turn and talk to your neighbor, and I want you to use, remember our learning for the day was to connect what we know about whole numbers to whole numbers and fractions. So I'm wondering, remember we talked earlier about the last one, how can you use that information to help you figure out which one is correct? Which one is correct? Turn and talk to your neighbors. What do you think? And why?
To me, I think when it equation-wise, the second one is correct because there's 3 groups and 1/2. Now you have a group of 3.
What do you guys think? Are you talking with your partners? Should it be 1/2 times 3 or should it be 3 times a half? What do you think? 1. What does that first number tell you? What does this multiplication sign tell you? Groups of. So how many groups were there? 3. And if this says groups of, how should we write our equation? Okay, so let's come back together. Uh-oh, it went off again. Oh no. I know, what am I doing? Okay, so let's talk. Which one did y'all think, well, I'm hooking us back up. Which one did y'all think should be the right way to write it? Yeah.
3 times 1/2 equals 1.
They said 3 times a half equals 1 1/2. Would you agree with that?
Yes, ma'am.
But why? I thought it doesn't matter. Like 3 times 4 is the same as 4 times 3. Isn't it? Yeah? So why does it matter how we write that?
There's 3 groups of 1/2 versus half a group of 3.
Oh, say that one more time.
There's 3 groups of 1/2 versus half a group of 3.
So in the problem, we saw how many groups? 3 of 1/2. Would you agree?
Yes.
So we had to write it 3 groups of a half because like our first problem in number sense, it mattered that we had that many groups of a certain size, right? So then the second one, can you ever write a half of 3? I want y'all to think about that. Could you ever write a half of 3 as we look at one more solution? If I can find it, hang on a minute. This was it right here. So now I want to, we talked about this one. So how far did Sam run in 3 days total? The product was what? 1 1/2. So you guys, I'm going to have to annotate again, right y'all? If I want to write.
Yes,
Annotate. And then, so we said that was 3 groups of 1/2, and our product was what? 1 1/2. Where we landed. There's our 3 groups of 1/2. We had 1/2 on each of these. Agree? And we landed at 1 1/2. So, looking at Sam's, how far did he run on Monday? And how is this model the same but different than this model? How are these models the same but also a little bit different? Don't go away. It's going away. Okay, I'm bringing it back. Talk to your group. How are they the same and different on this? And how far did Sam actually run on Monday?
The models are the same. They come up with the same number, and they have the same number of groups. They have the same number of groups, and they come up with the same number. What difference is this? One of them has an equation, the other one doesn't.
Sam has an equation and John don't. And I don't see the equation.
All right, let's come back together. First of all, how far did Sam run on Monday, according to this model? He ran 3 miles total, didn't he? Yeah, he ran 3 miles total in that, Monday and Tuesday. But the question asks, how far did he run each day? So how far did he run on Monday? 1 1/2. Do y'all see that? So what does this jump represent? What does that jump represent? Turn and tell your neighbor, what does this jump represent? And then what does this jump represent?
That first number represents days, the next number represents the second day. Or one of my neighbors and another one.
All right, so let's come back together. So what does this jump represent? Monday, and this is Tuesday, right? And so we had our 1 1/2. So how was this different, though, than the last one? How was it, what y'all talk about in your groups? How was this one different than the last one? Yeah, go ahead, Bella.
On the first one, he took 3 days to run 1 1/2 in total. And on the second one, he took 1 day to run 1 1/2.
Okay, so this one it took 3 days to run 1 1/2 miles, and this one it took 1 day, right? Bella, talk to me about what you were saying. Share with the class about how you figured out the answer here. What did you do to the 3 miles?
I divided 3 miles in half because
Oh, freeze right there. Did y'all hear what she said? Turn and tell your neighbor what she just said. Oh, say it louder, Bella. I'm not sure they heard you.
I divided 3 miles in half.
She divided 3 miles in half. Turn and talk to your neighbor about why she chose to do that instead of making 3 groups of a half. Turn and talk to your neighbor. Why did you choose to do that instead of making 3 groups?
Miles and have to figure out how many miles you went each day.
Okay, what do y'all think? Why would Bella choose to do that? Why would Bella choose to divide it in half? Wait, I thought we were doing multiplication. I'm so confused. She divided this in half. Why'd she do that instead of making 3 groups? Trey.
Because it asks you how to, how far did he run each day, so you have to figure out if he ran 2 days, you have to divide that in half.
Okay, so it said he ran half of that on each day. Is that what you're saying?
Yes.
So, if he ran half of it on each day, that's not the right one, is it? Then we just took the line. She even said I could fold that line up and put it in half. Would you agree?
Yes.
But we end up with the same answer. 1.5 is how much he ran each day, and 1.5. So how did we get? What do you think now, knowing that this was the multiplication equation for this? What would the multiplication equation be for the bottom one? Would it be the same, or would it look different? Try to talk to your neighbors. Would the equation look the same? I think it would be different, actually. Okay, so let's come back together. What do you think? What's the vote? What's your partner say? Should it be different or should it be the same, the equation? What do you think?
I think it's different.
You think it's different, why?
Because it's divided by multiplication. So that's why it's like kind of different than multiplication.
Okay. He's saying because she divided it in half, he feels like it has to look different. Because what does this sign mean? Groups of. But with multiplication, or when we start using fractions in our multiplication, which you guys are about to start working on, you have to think about that a little shift in the meaning of that sign. So it means groups of. So what do you think we would write as our equation? I'm trying to remember if I put one up here or not that did it. No, I don't think I did. So what do you think the equation would be? Oh, well, there's these two. If this one represents this line, what do you think this one represents? What do you think? You think? So we ended up with the same answer. Just like 3 times 4 is 12 and 4 times 3 is 12. Doesn't matter because they commute, right? So if we have 1/3 times, oh, not 1/3, Miss Lovelace. Oh, this is a half. I'm asleep now. 1/2. Okay, come back to me. 1/2 times 3 is 1 1/2. Would you agree commutatively these are the same answer? Would you agree? It doesn't matter what order. But the models, remember our model from the first one? We couldn't write 6 times 4 because there wasn't 6 groups. But wait, is this a half a group of 3? Can you think of it like that? Is this half groups of 3? What do y'all think? Can you think of that multiplication sign as half of groups of? Does that sound weird? Sounds a little weird. So when you think about for fractions, when your fraction is first, we're taking half of 3. So when you're multiplying, remember our similarities and differences that you all talked about? This, there went my sign again. The first equation, or the first model, was 3 groups of a half. That's what we learned in 4th grade. That's what we learned in 3rd grade, about groups of. But in 5th grade, you're going to start learning that when the multiplication, the first factor is a fraction, it doesn't always mean groups of. You can kind of think about it, a half a group of 3. But if you use the word of instead of groups of, doesn't that make sense? If I said a half of 3, here's my line, right? And that ends up with the same answer, but a different model. So I want you to talk now, going back to our learning intention for the day, which was to connect multiplication for whole numbers to that of fractions and whole numbers. And I want you to think about, what is the connection? What was the same, but also what was a little bit different? Turn and talk to your neighbor. We're going to share out, then we'll get ready for our exit ticket.
Same was how
talking to your neighbors a lot today. Let's wrap this up. What was the same about multiplication of the whole numbers and multiplication of the fractions? What did you notice was the same? Yeah, go ahead.
The same is like what I said, I don't know, it's kind of different, but division is like the same as multiplication.
Okay, division is the same as multiplication, and so that second problem was very much like I was dividing, even though it was multiplying, because I'm taking a half of 3, I'm dividing it in half. Okay, but what was the same in that first one? That first one, when John ran 3 miles for 3 days. What does that equation mean, that first factor? Y'all remember? Remember we had 3 times a half? And the answer was 1 1/2, and you guys did a beautiful job of modeling that on your number line. Beautiful job. You showed me the 3 groups, the number of groups, and you showed me the half. So what did this sign mean here in this one? Groups up, right? Remember you said, so how is that the same as whole numbers? Is it the same? Yeah. Because then remember our whole numbers, 3 times 4, we had 3 groups of 4. Would y'all agree? We had 3 groups of 4, now we have 3 groups of a half. No different. I'm still making 3 groups, I'm putting a half in each one. I'm making 3 groups, I'm putting 4 in each one. I'm making 3 groups, putting 100 in each one. Doesn't matter. Multiplication is 3 groups of this size. But what was the difference when we changed it to a half times 3? It's still got the same answer, but what was the difference that you noticed now? What is it, how did it change? Try to talk to your partner one last time as I hand out your exit tickets. How did it change?
Because you have 3 groups of half versus 1 half.
Okay, so how did it change that second time when we wrote a half of 3? How did it change? Tell me something your partner said, because then if it's wrong, your partner said it, right? Y'all are not very lively today. So, what do you think? How did it change? The first one was 3 groups of a half. What's the second one? Thank you. A half of 3. So I'm going to need you to remember that when you start doing fractions of fractions, doing multiplication of a fraction times a fraction in a few days, that when the fraction is the first factor and it means of, that's going to be important. That you're taking a half of 3 or a half of maybe a 4. Can you take a half of a 4? You'll find out in a few days. Thank you guys for letting me come and teach in your class today. You have a little exit ticket, 2 little problems. If I can read it, I'll read it to you. What is represented by the model? So I'm looking for an equation. Looking for an equation. There's 2 different models there. I'm looking for what equation there. If you want to give me a little explanation, that'd be great. Hope you guys have a great rest of your day and the rest of your